Okay, so welcome along to the second revision sheet for Algebra Level 2. We're doing revision sheet number 2 for the achieved level, Okay, so question number one. Question number one is just an expand question, and we are going to expand these two brackets here, and then we're going to have to do something with this here first, second. So the first thing you want to do is, I want to do is I want to expand these first two brackets here. So I'm going to go 5x times 3x, which is 15. 5 times 3 is 15, and then x squared, because x times x is x squared. And I'm going to go 5x times negative 2. Remember that that's a negative 2. So 5x times negative 2 is negative 10x. And then I'm going to go the second part. Now I've multiplied everything by that 5x. I don't need to multiply this part of the 5x because it's not part of these brackets. Okay. So now I'm going to go 4 times 3. So it's going to be plus, I'll get rid of that blue. It's going to be plus 12x. And then I'm going to go 4 times negative 2, and 4 times negative 2 is negative 8x. Now all of that is in one big bracket. Okay, those are brackets, sorry about the scribbling, and then I'm going to tag on this part here at the end, because I haven't really done anything to that yet. So it's going to be 4 2x minus 1. Right, now I can do a bit of simplifying. So I can look at this and I can say, okay, that is a negative 10x, that's a positive 12x, that is a negative 8x, and actually I have done something wrong. That there should not be a negative 8. If I go right back here, look at that, 4 times negative 2, it should be just negative 8. There is no x attached to that, because 4 times negative 2 is 8. So I can therefore get rid of that, because it doesn't have an x. But both of these have an x, so I can add those together. And negative 10 plus 12 is positive 2x, and then I can put that negative 8 there. Now I can get rid of the brackets. There's no negative in front of the brackets here, and so I can just leave it like that. And then again I'm going to tag that on, negative 4 2x minus 1. Now because this is an expand question, I need to get rid of these brackets, so I'm going to do that. And I probably could have done that up here, but that's okay. I'm just doing it nice and slowly. So this will all be the same. And now, remember, this, it's very important, this here is a negative. So it's going to be negative 4 times 2x. And negative 4 times 2x is negative 8x. And then negative 4 times negative 1, doing negative 4 times negative 1 now, is going to be negative, it's going to be positive, because a negative times a negative equals a positive. Okay, so negative 4 times negative 1 is positive 4. Now again I need to simplify, so I can look and I can say, okay, I have an x squared there. Are there any other x squareds? No. I have an x there. Are there any x's? Yes, there's an x there. And I have an 8 here, which is a number, and a number by itself there. So I can add those two. I'll leave the 15x squared because that's no other blues, but I can add these x's together. So 2x minus 8x would be negative 6x, and then negative 8 plus 4 is negative 4. And so that's the answer to the first one. Just sliding across here to the second one. Second one, we need to solve quadratic equations. So the first thing I need to do is to be able to solve a quadratic equation is to make equation equal 0. Okay, I need to make it equal 0. So in that case, I need to get rid of this 66. I need to get rid of that 66. So to do that, it is plus 66. So I can minus 66 from this side. And I can minus 66 from this side. So if I minus 66 from positive 66, it'll give me 0, and I'll be left with, I'm going to put the negative 66 here, just after the x, so it looks neat. So the 3x squared will stay the same, plus 27x minus 66 equals, in this case here, it equals 0. So once I've got to that step, that's my sort of first step, then I need to factorise, do my next step. Now, this is a hard factorising one because it's got a number here in front of the x. However, if I look at this number and this number and this number, and I ask myself, do they have anything in common? I can answer yes. And the thing they have in common is that they all can be divided by 3, i.e. there is a common factor of 3. So what I can do is, I can take that 3 and put it outside a bracket, and then ask myself, 3 times what gives me that? It's x squared. 3 times what gives me positive 27x? It's plus 9x. 3 times what gives me negative 66? That'll be negative 22 equals 0. Now, if I want to make it easy on myself, I can actually just, I'm going to try and get rid of that 3, and because the 3 is timesing that whole thing, to get rid of it I will divide by 3. So I'll divide that all there by 3, I'll divide that there by 3, and that will cancel that out, and I'm left with x squared plus 9x minus 22 equals 0 divided by 3, oh my goodness, is actually 0. So the beauty of taking the 3 out of all those things there and putting it outside the bracket is that by doing that, when I divide by 3, I'm still going to get 0 over here. So that is actually the same as that, in a way. And so now I've got a much easier factorising thing, much easier. So remember with factorising, you need to find a thing that adds to that, and times is to negative 22. Remember that negative is part of it. So over here I'll do that. So 1, and what give me 22? 22. 2 times what gives me 22 is 11. 3 doesn't go into 22. 4 doesn't go into 22. 5 doesn't go into 22. So on and so on and so forth. Nothing else goes into 22 until I get back up to 11. Okay? So, which one of these pairs, this one or this one, adds to positive 9? It will be that one there. And which one, if let's pretend that it was a, let's get rid of that circle. Let's pretend that it was a positive 2 and negative 11. If I add those together, that would give me a negative 9, which is not what I want. I want a positive 9. So therefore it would have to be a negative 2 and a positive 11, and that does give me my positive 9. So using those two numbers, I just put them into brackets, x plus 11 and x minus 2 equals 0. Note how I've kept this 0 the whole way down. Make sure you're doing that. Don't just regress to or fall back on just writing this part and ignoring that 0. It's very important it stays there. Now I come to, remember, if I have two things, y times x, and they equal 0, just a little time sign, sorry, y times x equals 0, either one of them must be 0, or both of them must be 0, okay? So if I think about it like that, these two here, that's my y and it's my x. Either this here is 0, x plus 11 equals 0, or x minus 2, equal sign, minus 2 equals 0. X plus 11 equals 0, therefore x would have to be, what plus 11 equals 0? Well, x would have to equal negative 11, and I could get that. Another way of doing it would be to minus 11 from this side, and minus 11 from this side, and those things there will cancel out, and I'm left with x, and 0 minus 11 is negative 11. Or, in this case here, I'll do the same thing. To get rid of that positive 2, I add 2, do the opposite of it. Add 2, because I'm trying to get to 0. Look at that, they cancel out, that's what I want. And so x equals 2. 0 plus 2 is 2. So, over here, I can finally write my answer. I'll just erase this here, so I've got a bit of room. My final answer will be, to this, solving that quadratic equation, is x equals negative 11, or I could actually put an or 2. Okay. And note how I put a box around that. And actually I'll go back over here and put a box around my answer here as well. Okay, on to question 3. Question 3 asks me to factorise this. Now this, normally we see factorising and we think of these sorts of ones. We think of things like that. So we've got an x squared and then an x and then a 2, and that's a very common format. When you see one like this, this is kind of the other format. It's not as common, but it is still around. The most common one would be something like if I have x squared plus 25. Sorry, it won't be plus, it'll be minus 25. That would be another one of these sorts of formats. And the way you solve them is you create two brackets like this. You put an x there, put an x there, then you put a plus and a minus. It's always a plus and a minus. And then you figure out what is the square root of 25. And in this case, that would be 5. And you put a 5 there and a 5 there. So we can definitely do that with this part here. We can definitely do that with this part here. I'm just not going to put the x in yet. I'll start using black, sorry. So we can definitely do that with the second part of this, because the 49 is similar to the 25 and there's a minus, okay? So it'll be a minus and a plus. And in this case, the square root of 49, that equals 7. 7 times 7 is 49, and there's a button under the calculator that looks like this. So I can put a 7 there and a 7 there. The 16k squared is a little bit trickier. Put a k there, put a k there, okay? But if I go k times k, I don't get 16k squared. I only get k squared. I'm missing that 16. So actually what I need to do is I need to figure out the square root of 16 as well, okay? And so the square root of 16 is 4. Put a 4 there and a 4 there. So 4k minus 7 and 4k plus 7. Let's to make sure, let's just check that out. Okay, so I'm going to go this times this, and I can check by expanding. That's what I'm doing. 4k times 4k, 16k squared, and then 4k times positive 7 is plus 28k. Now I can go negative 7 times 4k. It's going to be negative 28k. And then negative 7 times positive 7 is negative 49. Okay, and then I can go through and look, these ones here are the same. However, negative 28 plus 28 is simply 0. So my final answer is 16k squared minus 49, and that's what I wanted. Okay. However, that's not my answer to this question. That was just me checking. So I'll get rid of that. I'll get rid of all these things up here, and I will put it in my answer in a box. So that's it there. It's actually easier than the ones that you normally see. However, you can forget how to do them. Right, solving exponential equations. As soon as I see an x up top in the exponent area, I know I need to log it. So I'm going to log 1998. And I'm going to log, whenever I add a log to one side, I need to add another log to the other side. Or if I take a log away from this side, I need to take a log away from that side. So once I've done that, I can go log 1998. Nothing's going to change there. And the beauty of logs is I can take that x now, which is up in the exponent area, and bring it down and put it in front of the log. So it becomes x log 2, and there's an invisible time sign there. Okay, there's an invisible time sign there. So how do I get rid of that log 2? Remember, I'm trying to, in all equations, whenever I'm trying to solve an equation, I'm trying to get to x equals. Just like up here, in my quadratic equation, I was saying I'm trying to get to x equals something. In this case, it was two things, but in this case, it will just be one. That's what I'm trying to get to. I'll get rid of that just in case the marker thinks that that's my answer there. So I'm trying to get to x equals, so I need to get rid of this log 2 here. And to do that, because it's timesing, I can divide that by log 2, and then I can actually divide this by log 2 as well. These things here will cancel out, and I'll be left with x, which is great. Okay, so x equals log 1998 over log 2, and that equals, and this is where you need to get your calculator out. And so on my calculator I press log, and then I press 1998, and on my calculator I need to close the brackets. Okay, and most of yours will just say log 1998, but if you press log, if it goes and it does something like this on your calculator, log, and it opens a bracket and says, and then you put 1998 in, you need to close that bracket off. Okay, and then you need to press, this is the important part, press the divide button, and it becomes log 2. And that's what I press on my calculator, and that will give me an answer. And in this case, it gives me 10.96, and that's because I've rounded it. I need to put to 2 dp, and then because it's my answer, I put it in a box. Okay, moving on to question number 5. Question number 5 is exponents. These are some of the harder achieved questions. So if I have one that looks like this, I firstly say, oh dear, because it looks quite hard, but it's okay, we'll work it through. So the first thing, whenever I see something like this, I need to get rid of a negative exponent. Okay, and the way I get rid of a negative exponent is by flipping it upside down. So if I keep everything else the same, so keep this the same, keep that the same, but I'm just going to flip that bit there upside down. So this is equal to brackets p, and it will now be 1 over p to the power of 2/3, but it will be a positive 2/3 now, and it's still times. There's an invisible times sign here, the invisible times sign, so it's still times q to the power of a half, and it's still to the power of 3. If I have a fraction like this, and I'm going to times that by that, I can actually just times the top part here by that part there. Okay, so I'm just going to go that part there times that part there. So that will equal q half over p 2/3. Can I simplify that there? No, I can't, and it's still all to the power of 3. Whenever I have a 3 here, if there was a big number, I would go big number. We'll make it 48 to the power of 3. But when there are exponents like x, I just times. So I'm going to times those things there, and I'm going to times these things here. So q to the half times 3 would be q, again when you times a fraction by, it's exactly the same as up here. I'm going to actually just times the 1 part and the 3 part, just like the q and the 1 part times. Okay, so it becomes q 3 over 2 over, and again it will be 3 times the 2. There's the 3 times the top part, so p 6 over 3, and that equals, that can't be simplified anymore, that's just 3 over 2, and this here is 6 over 3 is 2, so it becomes q 3 over 2 all over p 6 divided by 3 is 2. Now just that, that's actually your answer there, but just as an aside, I'm going to make sure that you understand turning that into a surd if I really wanted to. This, and by a surd I just mean a square root thing. So if you wanted to, you could go q, and it would be q cubed, and then it will be the square root. So put a 2 there, or you could just leave it blank actually, because a root automatically suggests that it's a square, over p squared, if you wanted to. But that's more complicated than that, so you wouldn't actually do that. But just so you understand how those fraction things work, a bit more extra practice. So that there, the answer, I'll put a box around it and move on to the next one. So next one is to the power of -2. I immediately see that and know I need to flip it. Okay, in this case here I can just flip it. There's not over 1 or anything, so I just flip it upside down. So that equals 3p squared all over 2mn, and that becomes a positive 2. Okay, so that makes it a lot simpler. Now, the next step I need to do is to get rid of this positive 2 out here. And just like I was explaining in the question above, when you have a big number like a 3 here or a 2 here, it will become 3 to the power of 2 and 2 to the power of 2. Okay, so I'll do that part there. 3 to the power of 2 is 9. 2 to the power of 2 is 4. That, by the way, is coming from this thing out here. 3 to the power of 2, 2 to the power of 2. With the exponents, though, just like up here, you times the exponents, and there'll be an invisible 1 there, and an invisible 1 there. So it's going to be p, and then 2 times 2 is 4, and then n, 1 times 2 is 2, 1 times 2 is 2. And that there is my answer. I can't simplify these numbers anymore, and there are no m's or n's on the top, and there are no p's on the bottom. So that there, again, is my answer. Okay. Moving on to number 7. This is just a linear equation, it's not a quadratic one, so there should just be one answer for x. So I'm aiming for an x equals, and from your knowledge, you will know that you need to get all x's on one side first. That's the first step. First step for solving linear equations. So I've got an x here, and I've got an x here. So I need to change. I need to probably get the x's either on this side or this side. It doesn't matter. And to be able to move this x anywhere, I need to firstly expand those brackets. So it's going to be 5x plus 3, not doing anything to that side. 3 times 2x will be 6x, and 3 times 1 will be 3. Now I can move the x's over here and over here. Because I don't really want to minus 6x from that and end up with a negative x, I'm going to go moving that x to this side. Okay, so I'm going to get rid of that 5x. Currently it's a positive 5x, so to get rid of it I need to minus 5x. It's not multiplying anything, so I'm not dividing anything. So I'm minusing 5x from both sides. It will become 5x times 5x minus 5x is just 0. So I'm left with 3 here. And 6x minus 5x is x. And I've still got that plus 3 there. Now I need to remember get to x equals. So what's in my way? That 3 is in my way. I need to get rid of that. To get rid of that, it's a positive 3, so I'm going to minus 3. I'm going to minus 3. These things here will cancel out. And 3 minus 3 is actually 0. So x in the end equals 0. Right, moving on to inequations. Remember, inequations are just like equations, except they have a slightly different sign. I can treat that like an equals sign until or unless I need to multiply or divide by a negative number. So this is a slightly harder linear equation in that it's got a fraction. And when you have a linear equation and you have a fraction, the first thing you want to do is get rid of that fraction. So you want to make it kind of look like this, where it's all in one line, rather than having over 4 and over 8. So to do that, I need to get rid of that 4, I need to get rid of that 8. And to do that, I ask myself, well, what is that 4 currently doing to this side? It is actually, it's dividing, isn't it? Because the 4 is underneath, it's dividing, and that 8 is also dividing. So I'm going to get rid of that, I need to multiply. So I'm just going to do the 4 to start with. To get rid of the 4, I'm going to multiply this entire thing by 4. I'm going to multiply this entire thing by 4. By doing that, those things there will cancel out, because to times something by 4 and then to divide something by 4, we'll just leave it as itself. So I know that this side here will be 3x plus 5. On this side here, whenever I times something by 4, a fraction by 4, I just times the top part. Just times the top part. Don't times the bottom, just the top. So that's going to be less than, greater than 4, and then 6x minus 1, and that's over 8. So I've just times that by 4. Now I'm going to get rid of that 8. Okay, to get rid of the 8, again, similar to the 4, I'm going to multiply that by 8. I'm going to multiply this by 8. So what I'm left with is 8, and it's 8 times everything on this side. It's not just 8 times the 3x. So I need to show that by putting it in brackets. Like that. And I'm going to cancel those things out, because 8 times something, then dividing by 8 gets rid of it. And I'm left with 4, 6x minus 1. Now I'll need to expand these. So 8 times 3x is 24x. 8 times 5 is plus 40. Close that. And then 4 times 6x is 24x. And then 4 times negative 1 is negative 4. Now I need to get all the x's, just like up here, I need to get all the x's together. So I'm going to take the x's over this side here. Now I'm actually just looking ahead a little bit here and thinking, oh, I've got two 24x's. Have I done that right? And yes, I have. That's just how it's going to be. So to get rid of that 24x, I'm going to minus 24x, and I'm going to minus 24x from this side. And 24x minus 24x is 0, and 24x minus 24x is 0. So what I'm left with is we'll put the 0 over here, 0, I'm left with 40 is less than 4, which makes no sense. So I would just write over here, reject answer. Okay, because, and that's my answer essentially, because this here makes no sense. 40 is not less than negative 4. And so, even though we've done it all right, x is not equal to anything. And every now and then they will throw ones like that at you. Simplify rational expressions. To do this, I need to factorise, and then I'll cancel. And you'll always get one like this. So to factorise, I need to add times what adds to 7x and times the 12. Over here, 1 and 12 times the 12, 2 and 6 times the 12, 3 and 4 times the 12, and then I'm up to 4. So that's what I need to do. Which of those pairs adds to 7? It will be that one there, because 2 and 6 add to 8, 1 and 12 add to 13, 3 and 4 add to 7 though, so I can do that. Once I've got these two numbers, I just put them into brackets. So it's going to be x plus 3 from here, and then x plus 4 from here, and that's all over. The bottom one I need to do now as well, so I'm going to find one is plus the negative 1 and times the 12. So 1 and 12, remember this is a negative 12 and a negative x, so it's kind of like a negative 1x, that's what I'm adding to. I'm timed into negative 12. So it'll be 1 and 12, 2 and 6, and 3 and 4. Which of those, when I add them, will give me negative 1? Because of the negatives, it suggests that one of them will be a positive and one of them will be a negative. So when I add 12 and negative 1, I kind of get 11. Or if it was a negative 1 and 12, it would still be 11. Sorry, if it was negative 12 and 1, it would be negative 11. If it was a negative 6 and positive 2, it would be negative 4. And if it was negative 2 and positive 6, it would be positive 4. So none of these are adding to negative 1. In this case here, though, this one here looks, they're separated by 1, so that's probably going to be it. If I had a negative 3 and a positive 4, I added them, I get positive 1, and I'm after negative 1, so it can't be that. Maybe it is the other way around, so it's a positive 3 and a negative 4. Yes, that's a negative 1. So this here will simplify. So those two things there are my numbers. So this will be an x plus 3 and an x minus 4. Now, a useful thing to note is that in ones like this, you are really going to get things that cancel. So once you've got your top one, you should be looking for things. Oh, I missed the bracket there. you should be looking for things that you can cancel. So one of the things down the bottom will most likely be x plus 3 or x plus 4, and in this case, great, we have one of those which are the same, and they'll cancel out. Note that even though these have the same numbers, you can't cancel them out. They've got to be exactly the same. Okay, so that equals x plus 4 over x minus 4, and that there is the answer. Okay, right, moving on to number 10. Number 10 is just multiplying a fraction essentially, and when you multiplying is the easiest one of the fractions. You just multiply these, and you multiply these ones here. You multiply those and multiply those. Okay, just multiply on the top. So ACB squared, it's good to put it in alphabetical order. B squared C is the answer to that, and then BC squared. So BC, sorry, not squared, cubed. Now you can't just leave it there because you can simplify things. Are there any A's on the bottom? No, so I can just leave my A's. However, there is a B and a B. Now this B has an invisible 1 above it. Okay, it's an invisible 1. So I'm going to go 2 minus 1. Wherever the bigger one is, I just minus off that. So 2 minus 1, and 2 minus 1 is just 1. And because in maths we don't write them, I just leave it as that, but I could, if I really wanted to, write a 1 there. Because I'm doing it right, I won't do that. Then C's, there is a invisible 1 here. Invisible 1 here. Get rid of that negative 1 there. So there's an invisible 1 here, and so it's actually 3 minus 1. And because the bigger one is on the bottom, I'm going to minus off the bottom. So 3 minus 1 down here. So I'm minusing that 1 there from that 3. And in that case it will be C2. And because the bigger one is on the bottom, I put the C2 down there. And so that there is my answer. And again, I'll put a box around it, and I'll actually go back up and make sure I put a box around this as well. Right, next one, number 11. So this is a minusing 1, and so minusing 1 is the same as a plus 1. We have to use this cross and this drop method. They're the harder ones of the fractions. So I'm going to go along these arrows, and I'm going to multiply. So I'm going to go x times x minus 4, and that's going to be over here. So where the arrow is pointing up here, so it's sort of this part of the fraction. X minus 4, and I'll just leave it like this for now. And then over here on this side it's x squared times x plus 2. I might run out of room here. Okay, and then it's all over this bottom arrow here. X times x squared, that's x cubed. The only thing that I'm missing now is whatever that symbol there is. If it's a minus or a plus, I put that here in between the two things. Okay, so I now need to expand the brackets out just in case I can cancel things out. So I can go x cubed, because x squared times x is x cubed, and then x squared times positive 2 is plus 2x squared. Then I'm going to go, now remember this is a minus x, so it's a minus x times x. It's a minus x squared. And it's a minus x times minus 4. So minus x times minus 4 is a positive, minus times a minus is a positive, 4x. And that's all over x cubed. Final step, can I add any of these together? Or actually, I'm going to be able to cancel something. I'll add these together first, and then I will cancel something. So, if I look at these things here, 2x squared and x squared, I can add those together. This is an x cubed and this is an x, so I can't do anything about that. 2x squared minus x squared is just x squared. So x cubed 2x squared minus x squared is positive x squared plus 4x, and that's all over x cubed. Now, this is the thing that I can do. Note how normally you would just leave it at this point. Okay. However, I should always be checking, can I factorize it? Can I essentially do something like this? Once I've got, see, my answer is similar to that. Can I get rid of something? Can I make it simpler? And in this case, I certainly can. So If I look along here, I note that every single one of those has an x in it. So to be able to cancel anything, I need to get it to multiply. So the way to do that, I'll just look down here, is to factor it out. So I find the common factor, which in this case is x. Every single thing in there has an x. And I ask myself, x times what gives me x cubed? It's x squared. X times what gives me x squared? It's x. X times x gives me x squared. And x times what gives me 4x? Well, 4 times x gives me 4x. And now I'll put that over x cubed. And this has an invisible 1 above it. Okay, it's an invisible 1. And so I can go 3 minus 1 from this here and cancel these things here. Okay, so that is going to be equal to, all that's going to disappear and that's going to change to the squared. So it's going to be x squared plus x minus 4 all over x. 3 minus 1 is 2. And that there is my final answer. Okay? Don't do this. Don't put it through your work and make sure you have enough room. Okay? Right. 3 more to go. Firstly, I'm going to solve this log one. Now, this log one forces you to rearrange the log. When you see a log which is not a base 10, you know you're going to have to use that formula, or just the rearranged one. So to do that, the 3 stays exactly where it is, and it equals, the 9 goes up and across, 9 goes up and across, and the x goes up there. Okay, so now I've got 3 equals 9 to the power of what? If I don't know that, and I'm going to pretend I don't know what that is, the best way to do it is to actually re-log them and do a similar process to the one we will do down in question 14. So I'm going to log both sides. Log 3 equals, and then I'm going to log both this one here. And then I can bring that x down in front of this. That's the beauty of logs. I can go log 3 equals, and the x comes down in front, log 9. And now I can think, these invisible times sign there, so how do I get rid of this log 9? Because remember, if I'm doing a solve, I need to get to x equals. That's what I'm trying to get to. At the moment I've got a log 9. Don't want it there. So, x equals log 3 divided by log 9 because I divide. Actually, I'll just redo that. Make sure you fully understand that. So, if I think about it, these are timesing, so to get rid of that log 9, I divide by log 9. And I divide this by log 9. And therefore x will equal log 3 divided by log 9, which equals, again you have to get your calculator out here and go log, and the reason you get your calculator out is because you're solving, so log 3 divided by, and make sure you press that divided by sign, divided by log 9 equals, in this case it's 0.5 or a half. Okay, so I will put a around there, and I can always test that. I can go back to this point here and say, well, 9 to the power of a half, which actually is the same as half to the power of a half is the same as a square root, so square root of 9 is 3, and so that makes sense. X should equal a half. Question 13. Question 13, I need to get x by itself because I'm solving this equation. I'm solving the log, so I'm aiming to get to x equals. So x equals, to do that I've got to get rid of this log, and so to get rid of that log I need to get rid of this log. But to do that the 4 needs to be up here. I can't just get rid of the log because then the 4 disappears. You just can't do it, okay? So in that case I need to kind of use the reverse of why logs are beautiful and take that 4 and put it up here. So this will become log 5 to the power of 4, and now I can go, yes, I can go log x equals log, and it'll become 5 to the power of 4. 5 to the power of 4 is the same as 5 times 5 times 5 times 5, and that equals 5 times 5 is 25, times 5 is 125, times 5 is 625. So that will be log 65, and now, because they both have logs, I can actually just get rid of the logs on both sides, and I'm left with x equals 625. And there's my answer. Put a box around it. Move on. What is the log of a single number? This. So I'm after, in this case, I'm after an answer that just has a log and then a number here. Okay? So at the moment I've got a lot of logs and a lot of numbers, so the way I'm going to get there, this is different to using your calculator. You're not going to use your calculator for these ones, you'll just think of this as meaning the word simplify. You don't use your calculator for simplify, you only use your calculator for solving. So this one here, I need to be able to add these things. Firstly, I need to put all these things here up. Okay, and it's kind of a common thing they'll do, is they'll give you questions with numbers in front of the logs, you put them up. Okay, so this becomes log 4 to the power of 3 plus, and this becomes log 3 to the power of 2, and this becomes minus, and this is log 2 to the power of 3. Okay, the 3 goes up there, the 2 goes up there, and the 3 goes up there. So now I can go log, and I'll just solve all those. So 4 to the power of 3 is, 4 times 4 is 16, times 4 is, 4 times 10 is 40, times 6 is 24, so it's 64, plus log 3 times 3 is 9, minus log 2 times 2 times 2 is 8. And you don't need to do that in your head, you can just use a calculator for those parts there. So the last thing I need to do now is the actual simplifying. When I add two logs together, it is the same as timesing. It is the same as timesing the numbers in the middle there. 64 times 9. Okay, and so that there, I need to use my calculator for that. It's 576. So this is still minus log 8. So that's the same as log 576 minus log 8. And so now I'm down to two things. To do this, I need to minus two logs, and when I minus logs, so when I add logs, you times. Okay? When you subtract logs, you divide. See how they kind of go together? So this will be the same as a log of 576 divided by 8. And that equals log divided by 8. I'll use my calculator. 72. And so yes, I have my final answer, and I put a box around it. And so that is the end of revision sheet number 2.